our first example today, we're going to take a look at a shortcut for when integration by parts leads to more integration by parts, and sometimes more integration by parts. There's a technique we can use to kind of do it quickly instead of having to keep setting up the u, dv, v, du, all of that. It's called the rapid repeated integration by parts method. The setup is almost exactly the same though. We start by looking at the integral and identifying the u and the dv, the factor that will get more simplified when we differentiate it. That'll be our u. So I'll put it in my u column. And then the factor that can be integrated easily, cosine of 4x dx. And you'll see with this one, we don't really need to include the dx's when we're doing the rapid repeated integration by parts because of the shortcut we're taking. So what we're going to do in this case is integrate and differentiate each one. So we'll differentiate the u, integrate the dv, and just keep going until it's clear that we're done. So you'll see what I mean by that. We'll take the u and differentiate that. The derivative of x cubed is 3x squared. And then the antiderivative of cosine of 4x is the sine of 4x over 4. And we can look at that, and if this was regular integration by parts, this would be my v du, and the integral of v du, well, clearly we're not quite ready to just integrate that one quickly. So we're going to keep going. Take the derivative of the next u. The derivative of 3x squared is 6x. The antiderivative of sine of 4x over 4 is negative cosine of 4x over 16. And again, if I were done here, this would be my integral of v du, but not ready for that yet, so I'm going to keep going. The derivative of 6x is 6. The antiderivative of negative cosine of 4x over 16 is negative sine of 4x over 64. Each time I just keep putting another 4 in that denominator. And this time, if I had the, remember, we'd be minus the integral of v du. Well, that integral, I could do that integral because now it's just a trig function. So that one wouldn't be so hard. But I will say that you can keep going to make it a little bit easier. Again, take the derivative of my u and the antiderivative of my dv. So that's a negative sine of 4x over 256. Sorry, not negative sine again. Positive cosine. And so now I'm done, because now if I were to try and take the integral of v du, it would be the integral of 0. And I know the integral of 0 is just 0 plus c. So that means I'm going to be up to my plus c. I'm done. Okay. And if you remember the way we set up our integration by parts, the formula involves the product of uv. Well, this is my u, and this is my v. But in the next row, this is my next u, and that's my next v. And that's my next u and my next v. So what I'm going to do is keep making these connections, these diagonal connections, because each one of those diagonals is a uv pair. So I'm going to look at all of those products. But there's a tiny little catch here. When I connect those products, the first one is nice and simple, the product of u times v. But with the next one, if you remember the formula from integration by parts, it would be the integral of this. It would be minus the integral of this. It's uv minus the integral of v du, which means when I go to my next diagonal, which would be my next uv, remember there'd be a minus sign in front of it. So what I'm going to have to do is change the sign of the next diagonal. And then there would be a minus sign again, so I would be changing the sign again. So switching the sign. Every diagonal, I'm going to switch the sign from what the previous one was. And then in the end, my last step is always going to be this plus c. So here's my shortcut, that the integral of x cubed times the cosine of 4x in respect to x is going to be the sum of all of the products I just made with those diagonal red lines. X cubed sine of 4x over 4. Notice my next product was negative because it's 3x squared times negative cosine of 4x over 16, but there's also a sign change, so those two negatives actually cancel out. So it's plus 3x squared cosine of 4x over 16. And my next product is again negative 6x times negative sine of 4x over 64. And this time the sign change makes it be the positive version of that negative product, which sounds a little bit backwards, but all that means is I'm just still keeping my negative sign. You can feel free to reduce here if you want and make that 3x sine of 4x over 32. Just reduce that 6 over 64. And then my last term, the product itself would be positive, but there's a sign change, so it's subtracting 6 times the cosine of 4x over 256. And again, if you want to, you can reduce the fraction, might as well. 3 times the cosine of 4x over 128. And then that last integral will be minus the integral of my final VDU would be just 0. So the integral of 0 is just some unknown constant. And that's where the final plus c comes in.